So hi guys, mayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about finding the sum of terms of an arithmetic sequence. This is the continuation of the lesson in my previous video about finding the nth term of an arithmetic sequence. Still, this is for junior high school mathematics, specifically for grade 10 students. So sum of terms of an arithmetic sequence. When we say finding the sum of terms of an arithmetic sequence or sum of terms of an arithmetic sequence, it is called an arithmetic series. So what is therefore an arithmetic series? For example, we are given this arithmetic sequence 1, 4, 7, 10, and 13. In this sequence, we have 5 terms and our common difference is 3, which is 13 minus 10, 10 minus 7, 7 minus 4, and 4 minus 1 will give us a constant number which is 3, and that is called the common difference. So when we say an arithmetic series, it is the sum of all the terms in a given arithmetic sequence. So if we are given this sequence, we can write this one as 1 plus 4 plus 7 plus 10 and plus 13. So this is what we call the arithmetic series, and that is the sum of terms of an arithmetic sequence. Now to proceed, in finding the sum of an arithmetic sequence, we have to remember two formula. The first formula is S sub n equals n over 2 times a sub 1 plus a sub n. We have to remember that this formula can only be used if the sequence is a finite sequence. So we cannot use this formula if the sequence is infinite sequence because we do not have the last term. For finite sequence, we have the first term, we also have the last term. This is our first formula. The second formula is S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d, which is the common difference. Now we have to remember that this formula can be used if the sequence is finite sequence or infinite sequence. So we can use this formula either finite or infinite sequence. But the first formula can only be used if the sequence is finite. It has the first term, it has the last term. Now in this formula, of course, our a sub 1 is still denoted as the first term. Our a sub 1 here is the first term. Our s sub n is now called the sum of terms in an arithmetic sequence. Then the d is the common difference. And of course, our a sub 1 is the nth term. Now to proceed, let us try this example. For example, you are told to find the sum of the first 20 terms of the arithmetic sequence 5, 7, 9, and 11. Since this is a worded problem, we need to identify the given. So, our first term, which is a sub 1, is of course 5, and the common difference is 2. So, how did we get 2? We just simply subtract 11 minus 9 is 2, 9 minus 7 is 2, 7 minus 5 is 2. So the constant number, which is called the common difference in this sequence, is 2. Next is our n is 20. So how did we get 20? Since we are going to find the sum of the first 20 terms. So there are 20 terms that we need to add. And of course, we have to find the S sub 20, which is the S sub n. This time, since our n is 20, so that is S sub 20. For the solution, we need to use the formula S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times the common difference. So, we substitute these values to the formula. So, instead of writing S sub n, this will now become S sub 20. Because we are going to find the S sub 20. Then our n is 20. We copy over 2 times, we copy the 2 here. Then our first term is 5, it's given. So that's why we write 5 here instead of writing a sub 1. Then we copy plus. Our n is 20. We copy minus. Then of course our common difference is 2. So we write here 2. Next is we simplify. So 20 divided by 2 is 10. Then we have here 2 times 5 is 10. Then 20 minus 1 is 19 times we copy the common difference which is 2. We simplify the terms inside the parentheses. We have 19 times 2 is 38. Then 38 plus 10 will give us 48. Then 48 times 10 will give us 420. So therefore, the sum of the first 20 terms of this given sequence will give us 480. That is 5 plus 7 plus 9 plus 11 plus 13 plus 15 and so on until the 20th term will give us 480. Okay, so let's proceed to another example. Example number 2. Find the sum of all even integers from numbers 2 to 100. This time, this sequence is a finite sequence, but we will be using first the second formula and we will compare the result to the first formula. So, since we are going to find the sum of all even integers only, so excluding the odd integers, that means we are going to add 2, 4, 6, 8, 10, and so on until 100. So, let's identify the given. Of course, since we are given our first term, which is 2, a sub 1, then our d is 2. So how did we get the common difference 2? Since we are only going to add the even numbers, so that gives us 100, which is the last term, minus 98 is 2, 98 minus 96, 96 minus 94, 94 minus 92, and so on until 4 minus 2 will give us 2 as our common difference. Next is the number of terms. Since there are 50 even numbers from 2 to 100, if we are going to count 2, 4, 6, 8, 10, 12, 14, and so on until 100, that is 50. There are 50 even numbers from 2 to 100. Another is we have to solve for S sub 50 since there are 50 terms. We will use the second formula first. We have S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. So S sub n, of course, we have to find S sub 50. That's why we have here S sub 50 equals our n is 50 over, we copy 2, our first term is 2, we copy plus, our n is 50 minus 1, the common difference, which is 2. Then we simplify. 50 divided by 2 is 25. 2 times 2 is 4. Then 50 minus 1 is 49. Then we multiply that with a common difference, which is 2. So 49 times 2 is 98. Then we add that with 4 here, 102. Then 102 times 25 will give us 2,550. So the sum of all even integers from numbers 2 to 100 is 2,550. Now this time, we will try the same problem using the first formula. So example number 3. Still, find the sum of all even integers from numbers 2 to 100. The given, our first term is 2. Then our a sub n, which is the last term, is 100, or that is a sub 50. Our n is 50 and we are to solve for s sub 50. Now as you have observed, we do not have the common difference now as the given because we will no longer use the common difference. So for the solution, we use the first formula, s sub n equals n over 2 times the quantity of a sub 1 plus the a sub n. So we substitute. S sub 50 is equal to 50 over 2 times our first term is 2 plus the last term, or A sub 50, is 100. So 100 plus 2 will give us 102. Then multiply this one to 25 is of course 2,550. So as you have observed, we have the same value, 2,550, using the second formula. Now let's proceed to example number 4. The sum of the first 14 terms of an arithmetic sequence is negative 413. If the last term is negative 62, this is term, not terms. If the last term is negative 62, find the first term. So this time, we are given the sum of the first 14 terms, which is negative 413. And we are going to solve for the first term. So if we are going to identify the given, we have a sub 1, which is the first term, is unknown since we are going to solve for the first term. Then our a sub 14, since we are going to solve for the first 14 terms and we are given the last term, which is negative 62. So our a sub 14 is negative 62. Then our n is, of course, 14. Then our s sub 14 is given since we are given the sum is negative 413. So for the solution, we need to use the first formula since we are given the last term, which is negative 62. So we substitute, we are given s sub 14, which is the sum, which is negative 413, equals our n is 14, then divided by 2, the first term is unknown, so that's why we copy a sub 1, plus our a sub n is negative 62. Then we simplify, we divide 14 by 2 will give us 7. Then positive times negative will give us negative. That's why we have here negative 62. Then we distribute the 7 to the terms inside the parentheses. So we copy negative 413, then 7 times a sub 1 will give us 7, a sub 1. Then we have 7 times negative 62 will give us negative 434. Now, since we are going to solve for the first term, we have here 7a sub 1. We need to eliminate negative 434 here. So that's why we need to use addition property of equality. So we have to add 434 here at this side of the equation so that we can cancel this out. Of course, we will also add 434 to the left side of the equation. So this becomes negative 413 plus 434 will give us positive 21 equals we copy 7a sub 1. Then since we are only going to solve for a sub 1, which is the first term, we need to eliminate 7 as the coefficient of a sub 1. So we divide both sides of the equation by 7. So we can cancel out the 7. So what remains, we can now interchange. What remains will be the first term, which is a sub 1, and 21 divided by 7 will give us 3. So our first term for this given sequence is 3. Okay, so that's it. I hope you have learned something from this video. Please do not forget to subscribe, click the notification bell so that you will be notified for the new uploads in the future. Thank you and God bless.